Today's lesson, 3.1, is reading quadratic graphs. Quadratic graphs always make a parabola, and they're very realistic situations when it comes to throwing objects because of gravity and stuff like that. So check it out. Would you believe that this first graph is about the height of a ball that's thrown versus time? All good with that? What do the x values of this graph represent? Boom, right here, time in seconds. What do the y values of this graph represent? Height in feet. Height in feet. Then they ask some more serious questions. What is the initial height of the ball? Well, the initial height would be when the time is equal to how much? Like how much time has passed when you just got started? 0 seconds. So if you go to 0 seconds, do we know the initial height of the ball? 6 what? Feet. Labels are going to be the big thing. 6 feet. What is the maximum height of the ball? Maximum height of the ball is right here, 12.25 feet. Got to have the labels. How long did it take for the ball to reach its max height? It took 1.25 seconds. Does anybody know what this point is called again right here? It is the maximum, but on the parabola, that has a special name. What is that thing called? That is the vertex of the parabola. And this whole chapter, I shouldn't say the whole chapter, half of this chapter, that's a very important thing. How to find the vertex. We already did that last chapter. So what does the ordered pair 3, 0 represent in this situation? So it's all back to writing a complete sentence, and it's back to knowing what x stands for and what y stands for. If you laughed at me for having these questions on here of what x stands for and what y stands for, then I will laugh at you if you can't write the complete sentence. 3, 0. What does x stand for? What does x stand for? What does x stand for? 3. X doesn't stand for 3 seconds. What does x stand for? Time in seconds. What does this 3 in the x value stand for then? 3 what? And then what does 0 mean? 0. So we won't say that, though. It does stand for a height of 0, but we won't say that. What happens when the ball gets to a height of 0? What is that realistically? That is the ground. So what would you like this to say? Would you like this to say the ball hits the ground after 3 seconds, or would you like to say after 3 seconds the ball hits the ground? Which one of those do you feel is correct? Words. Because x comes first, we have to mention stuff about x first. So we'll say after 3 seconds the ball hits the ground. This is about x. This is about y in that case. Like I said, real short chapter, man. So this test is coming up fast. These complete sentences and these labels and all this stuff is the most important part probably. You could still get every question right, kind of, but get a C on the test just for not putting it in a complete sentence or not answering the sentence the way it's supposed to be. So after 3 seconds, the ball hit the ground. Sound cool? Always talk about x first, y second. Sweet. Let's keep rolling. They give me a graph, and they say make a sketch of a ball that was thrown from an initial height of 28 feet, took 7 seconds to hit the ground, and reached a max height of 64 feet after 3 seconds. So let's take that one bit at a time. Let's put this on the graph, an initial height of 28 feet. Can you just put a dot, like a point, on the graph of where that was? The ball had an initial height of 28 feet. I kind of don't like the scale spread out so much. It gets 20, 40, 60, but they've got all these different tick marks in there. So I noticed that there's 1, 2, 3, 4 spots up there, so they're counting by 5. So I'm going to go sneak in some more deals on my scale just so I can read it a little more accurately. So I'm going to sneak in the 10, the 30, the 50, and the 70. Just because that's hard to read when they space it out so far apart. So 28 feet, so meow. Can't do that, though. I have no idea where that's at. You must do it like this, 0, 28. Now you have no doubt about where that's at. So put in the ordered pair. Sound cool? Took 7 seconds to hit the ground, so that's going to go here, right in the sun. And you got to put the ordered pair. Do I want 0, 7 or 7, 0? Yeah, just be careful. That's an easy ordered pair to get backwards, 7, 0. And then it's got a max height of 64 feet after 3 seconds. So 3 seconds is right here. 64 feet is somewhere up close to this guy. So bada boom. It's really close to that. So 364. And then we got to use our best sketching skills to kind of sketch a parabola that goes like this. It's going to go up to the max, and then it's going to have to come back down and hit that. So try your best. If you mess it up, erase it and try a better one in that case. Definitely can't use a straight edge because it doesn't happen linearly in that case. Use your sketch to approximate the height of the ball after 1 second. Go. Record this. I had a vote in class for 142, and I think that's fine. Everybody's is going to be a little bit off because we freehanded this parabola right here. So you got to go to 1 second. You don't need to draw this guy right here, but you just got to go up to see where it meets the graph. And I agree with that student that said 142 looks pretty darn close. If you have somewhere between like 40 and 45-ish, you know, I would probably accept it. What I have to do is literally see your graph and see what it looks like in that case based on how you sketched it. So I'm going to put about 42 feet. And we'll put approximate also because we just free-handed that thing in. We don't have an equation, so about 42 feet was fine. If you had 43 feet, whatever. Cool? And then I'll let you in video land think about these on your own right here. But you in class, I'll have you discuss number 9 real quick. So our thoughts were that if you go on the left side of this x-axis, time is negative, and you really can't do that. Yes, you can talk about stuff that happened in the past. You know, it's like I get that, but like you cannot go back in time to unthrow the ball or anything like that. So we don't have to write anything down. Let's just talk it out. How about if number 10 here, could the graph do this? Could the graph do one of those? Go under the y-axis, where that's where the height would be affected. Talk about that with your neighbor. The problems were all quadratic because they form a parabola. Quadratic graphs happen all the time. We could, if the drinking fountains were turned on, if we weren't living in a pandemic, you could go hit the button on the drinking fountain and doesn't the water shoot out in a shape of a parabola? Thank you, gravity. Where on the graph was the initial height of the... Ashley, you were the next person on the wheel when I accidentally spun it. What is the name of this point? Not 0, 6, but like... Not just 6. I don't. So because the graph starts on the y-axis, that is the y-intercept. The y-intercept. And then I'll go back to you, Ashley. What part of the parabola did the maximum height occur at? It happened right here. What's that thing called? That's the vertex. And then you and your neighbor see if you can figure out where the ball hit the ground at. The x-intercept. That is where it crosses the x-axis. That is the x-intercept. And this is all a setup for us to do the entire backside, which should happen pretty fast. The backside is about finding either the y-intercept, find the vertex, or find the x-intercept. Those are the basic ideas of this. Those 3 points are magic. And to preview our graphing calculator chapter, when we do this with a graphing calculator, we still need to know before we punch a lot of stuff in where the y-intercept is, where the vertex is, and where the x-intercept is going to be. Those are our important things. So we're going to find them by hand. First, for the y-intercept, it says, here's how to find the y-intercept. If I go back to this graph, would you believe that as an ordered pair, somebody is 0 for a y-intercept? Who is 0 every time? X is 0. It doesn't matter if it's at 0, 6, 0, 4, 0, 3, whatever. Wherever this touches, the x value of a y-intercept is always 0. So that's why to find the y-intercept of this, you're going to let x equal 0. So check it out. A ball was thrown in the air followed by this path. Meow, 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 meow. What is the initial height of the ball? Initial height means find the y-intercept. You might maybe even make a note, you know, if you wanted to. This is to find the initial height. Y-intercepts help you find the initial height of a ball or a thrown object or anything like that. And it's so easy that we don't even need a calculator because 0 is a very, very magical number. We're going to put 0 in for x. So I'll sub in You don't have to. You can just watch. So I'm not putting 0 in for y, so I'm going to get y equals. I'm going to put 0 in for this. Help me mentally. What's 0 squared? Times negative 16. It's like that goes away, right? That's nothing. Plus 48 times 0. How much is 48 times 0? It's nothing. It's like that goes away. And then there's 4 left. Right? Hey, what was the initial height of the ball, my friends? For what? For, I guess they don't tell us. Oh, it does up here. X stands for time in seconds and Y stands for height in feet. So we'll do 4 feet. That's the y-intercept, my friends. Because this parabola was in standard form, the y-intercept is this guy right here. That's the c value. You know, ax plus by equals c. Because when you let x equal 0, this nugget disappears, meow, and this nugget disappears. So if a rock was thrown in the air and followed this path, what is the initial height of the rock, my friends? That is what? 5 feet. Too easy. Right? What you really have to understand is the initial height is the y-intercept. How do you find the y-intercept? Let x equal 0 in that case. Next, read. Find the vertex. To find the vertex of a parabola. The good news is we just kind of did that in chapter 1. If the parabola was in what's called standard form, ax squared plus bx plus c. There's also vertex form of a parabola, which could be here in green. This is like what the purple note card parabolas looked like. It was in vertex form in that case, you know, where it had the parentheses and it was being squared and all of that cool stuff. So we have to recognize what form the quadratic is in first. Is it in standard form or if it's in vertex form? Standard form, we do the same old story. Opposite of b over 2 times a to find the x value, just like we did before, and then we sub that in to find the y value. But vertex form, bro, it's called vertex form for a reason. You could literally look at it and see what the vertex is. The vertex is always h comma k. So h comma k. H, remember, just like the purple note card, it's the opposite of what you think right here. So here's the h value. It's opposite game. Here's the k value. Talk to me. I'm just going to make some problems up. Y equals 2 times x minus 3 quantity squared plus 5. This is a parabola in vertex form. What's h? 3 or negative 3? It's 3. What's k? That's the vertex. 3, 5. You could look at it and tell me what the vertex is in that situation. This dude, y equals 2x squared plus 6x plus 11, is not in vertex form. That's standard form. You cannot look at it and see what the vertex is. You have to do some algebra. So here's our ball again. It's thrown in this path. Meow. Tell your neighbor real quick, is this in standard form or vertex form? He's in standard form, so let's go find the vertex. I don't care what these questions ask, you know. Well, I guess I do. I do care because they say the max height and the max height and the max height. On our sketch before that we had back here, isn't the max height always happen at the vertex? So the phrase max height is very important for us to know that we need to find the vertex. So I don't care about finding x first or y first or anything like that. I'm just going to do some algebra to find the x value of the vertex. What's my little formula? Opposite of b over 2 times a. I'm going to ask nicely. I'm not going to grade this. I'm just going to ask you nicely to write that down every time when you're finding the x value of the vertex. You know as well as I do, the more you write something, the more you remember it. Right? So please, if you write that down, I'll bet you will have 10 times the success when it comes to finding the values of the vertex. Opposite of b over 2 times a. Find the x value of the vertex, or negative 32. So I'm going to punch that in because that's probably a decimal. Was it 48 over 32, right? I know they're both negative, but guess what a negative divided by a negative turns out to be? Positive, right? So I think the decimals make sense in this story situation. Instead of reducing that to 3/2, doesn't 1.5 make a lot more sense for like this time in seconds? It's like, would you rather say it took 3/2 seconds or 1.5 seconds? So that's the x value. How do you go finding the y value now? We will substitute 1.5 in for x. To find the y value, we just got to put him in parentheses. So let me minimize this so I can see what I'm supposed to be typing. Negative 16 times 1.5 squared plus 48 times 1.5 plus 4. Boom. 40. That's what I got. So I'm going to write it as a ordered pair. And now I'm going to go back and answer the questions. I read stuff about max height. I wanted to find the vertex. I found the vertex, 1.540. What is the maximum height of the ball? Is it the 1.5 or is it the 40? 40 label, feet. How long did it take? 1.5 seconds. Questions about that? I found the vertex. Why don't you and your neighbor try number 17? Realize if it's in standard form or vertex form, and if it's in standard form, do some algebra. Because they mentioned the old max height, we need to find the vertex. Correct? So I'm going to do x equals opposite of b over 2a, negative 32 over negative 32. That's 1, right, for the x value of the vertex. Sub it in. Put 1 in for x, and what did you get for that? Spinny, 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 timeout, spinny. Yes, so we got 21 for a y value of the vertex by punching that in, and that would be 21 feet. And how long did it take, everybody? It took how long? 1 second. Don't forget the labels. Not too bad. Those were in vertex, those were in standard form. Standard form, ax squared plus bx plus c. Is this parabola right now in standard form or vertex form? Tell your neighbor. That's in vertex form. So the vertex should be h comma k. What is the vertex at? 2.5, 23, right? H, k in that case. What is the maximum height of this rock? 23 feet. How long did that take? 2.5 seconds. Like I said, not a bad day. Not a bad day at all. So far, we have found the maximum by finding the vertex, and we found the initial height by finding the y-intercepts. Now to figure out where the ball hits the ground at. It's the x-intercepts. There's a lot of ways to find the x-intercepts, guys. We got to let y equal 0. So if I could do this for a second. If you let y equal 0 on this guy right here, instead of me writing it all out, there's a lot of ways to do it. You could factor that. You could complete the square on that. You could use the quadratic formula. You could graph it with the graphing calculator and find the x-intercepts. What we're going to do today is use the quadratic formula. I wouldn't want to factor this. These numbers are too big. You got to frowny face factor this, dude. Take negative 16 times 4. That's negative 64. You'd have to find two numbers that multiply together to be negative 64 and add together to be 48. And that might not even happen. You might not even find those two numbers. So I think what we're bringing back this year is we're bringing back the quadratic formula. You have done very little of that in your math past. It's time to bring her back. Here's the hardest part about it. You got to know it. You have to memorize this quadratic formula. So let's do this. I have had way more success if students identify A, B, and C. I'm sorry that my pen's not working very nice here. Let's identify A, B, and C off to the side. A equals, come on, pen, work for me. B equals, C equals. Who's A? Negative 16. Who B? 48. And C is, come on, pen, work for me, work for me, work for me, is 4. Here's how I've been doing the quadratic formula since I was in 8th grade, which was a long, long time ago. 1993 was when I was in 8th grade, right? So fitting on decade day. Ever since then, since I've been 14 and now I'm 40 years old, I do the quadratic formula the same way. I have to say it to myself when I write these things down. I have these A, B's, and C's, and I literally do this, opposite of B. But I don't write opposite of B. I write negative 48. Isn't that the opposite of B? Plus or minus the square root of. Then I do B squared. I'm going to use my calculator to do that. I'm not going to punch it in on this screen because my computer's acting, so I'm going to do 48 squared by hand, and I got 2304. Did you get 2304? So I did the B squared part right here. Minus 4 times A, write it with parentheses, guys, because that's how we need to punch it in, times C, all of it over 2 times A. So I only figured out 2 things ahead of time. I figured out this, which is B squared, and 2 times A. I figured those 2 things out ahead of time. The next thing I want you to do is figure this out, the entire green thing. Forget about the radical, though. The radical has nothing to do with it. This is called the discriminant. You're going to hear lots and lots of questions about the discriminant. So let's just punch in the 2304 minus 4 times negative 16 times 4. Notice I use parentheses for all my multiplying also to make that larger for you to see. And figure this out. 2048, is that what you call it? Did I punch it in wrong? Oh, I got to do negative 16. Thank you. I made a mistake. 2304 minus 4 times negative 16 would make a difference, right? Times 4. Is that my C value? Did you get this instead, 2560? So just goes to show, we all type things in wrong. You know, it happens. So that's why I like these displays, though. You can see what you typed in. Hey, I wonder if this is a perfect square. Do you think it's a perfect square, 25? Because it doesn't have to get square rooted in this. Let's see if it's a perfect square. I'm going to square root this answer. Is that a perfect square? Nope. So that's going to be nasty town. So here's what we're going to do. These answers are going to be nasty. We're going to write down exactly what we had. The radical is still around it, but we're going to throw that discriminant underneath here, which was what again? It was 2560. So what we're going to do, this didn't come out very nice. We're going to punch this in. And it's not the easiest thing to punch in. We have to do the numerator first and then hit equals. And there's 2 answers up there because of this plus or minus. So let me do this. If I can get my calculator going on this pen, working very nice. Let me get this calculator going. Let's do negative 48. And let's do the plus first. Come on, calculator, work for me. Negative 48 plus the square root of 2560. I apologize for my calculator not working. I got to clear it out and start over. Negative 48 plus the square root of 2560. And hit equals, please. That's not our answer. What still needs to be done to that answer? We got to divide it by negative 32, right? So let's do that in our calculator. Divide it by negative 32. And that's going to be a really nasty decimal, and it's negative. We'll round that to 2 decimal places since it's really weird. So we're going to say about negative 0.08. About negative 0.08, one of those answers. Remember, there's going to be 2 answers. So about negative 0.08. Now we got to do the other one. An approximate in front of there. We did the plus. We got to do the minus in that case. So negative 48 minus the square root of that. And then divide it by negative 32. And then we'll get a positive answer of 3.08. Is that what y'all are getting? So there was 2 answers. Negative 0.08 or about 3.08. One of these is probably extraneous because remember we talked about that earlier. It can't take negative 0.08 seconds for the ball to hit the ground. Shouldn't it take about 3.08 seconds in that case? So let's cross this out. I want you to put them both, but cross that out, and we'll have to say approximately 3.08 seconds. So there's just one more, baby. They want to know how long it took for this rock to hit the ground. Let's use the quadratic formula. Let's do A, B, C, and then I'll let you substitute those in. This is in standard form, so that's nice. Substitute those into the equation, into the quadratic formula. Opposite of b, it's right in front of you on your paper if you're not sure what it is. I have subbed it in. Now I'm going to clean up my discriminant. Get rid of this for you all. The 1024. This calculator is really frustrated today. Sorry to everyone for having to put up with it. Times negative 16 times 5. I got a discriminant of 1344 all over negative 32. Don't try to cancel those out. That's a tempting thing to do, but it's got to cancel out with all three things before you can do that. So 32 definitely doesn't go into the square root of 1344. We'll just punch that stuff in. So negative 32 plus the square root of 1344. World's slowest calculator enacting here. Hit equals, divide by negative 32. And we'll always get one negative answer and one positive answer when we're doing these problems where the rock starts above the ground. So about negative 0.15. What was the other one when we punched it in? Negative 32 plus the square root of this, then divided by 32? 2.15-ish? Is that what we're getting? And we'll throw out the negative, and we'll throw seconds on this one. Quadratic formula. There's not very many homework problems, so please practice it well, and then we'll do more ways to solve a quadratic next time.